Hello, today we're going to do a Unit 4 review of congruent triangles. Okay, on number 1, first of all, we're going to go ahead and find x. Number 1 has two of our theorems going on right here. So with number 1, the first thing is the total degrees of a triangle. And that's the interior angle. So that's the total degrees of the interior of a triangle equals 180 degrees. So this angle, and this angle have to equal 180 degrees. With that, how do I know what this angle is right here? Well, easy, because we know that at the end of the unit, we learned that if we have an isosceles triangle, which means two of my sides, or at least two of my sides are congruent, that we can use something called the base angles theorem. And the base angles theorem tells us that if two of the sides of a triangle are congruent, then the base angles are congruent. The base angles are the ones that are opposite the side. So here is a side, 40 is opposite. Here is a side, this angle is opposite. These two angles here are congruent, so this angle here is also 40 degrees. So then now I can come back and say, all right, I know the total degrees is 180. I know the missing guy here was 40. So now I can just say 40 plus the 40 plus 8x minus 8 gives me the total degrees of my triangle, which is 180. So now I have, 80 plus 8x minus 8. So 72, sorry, I'm taking the long road here. So 180 minus 72 gave me 108. So x here is 13.5. And that's all I was looking for. It's a value, so I do not put a degree on it. It's just 13.5. When we move on to, oh, sorry, you didn't see that. When we move on to number 2. Number 2 is a theorem that we learned within the first section as well. The theorem tells us that the exterior angle is equals to the two non-adjacent interior angles. Well, right here is my exterior angle for the angle right here, which means that this angle is congruent or equal to the two non-adjacent angles. So 3x minus 2 plus 5x equals 150. Once I apply this theorem, I think it's called the exterior angles theorem, then we can go ahead and find x. So x is 19. All right, a lot of questions on your test are going to be in words, and you're going to have to draw a picture. So what you're going to have to do is figure out what's going on. It's a lot like your review in the capacity that it's going to give you a scenario, and you need to figure out what's going on. So it says, if I have triangle CDE and MNO. So let me draw them so I can see them. It doesn't matter what I draw them as. I'm just drawing a picture to get a visual. That's all I'm doing. Now it tells me that angle D is congruent to angle N. So I'm going to make my marking. Angle M is congruent to angle C. I'm going to make my marking. What must also be congruent and why? Okay, this right here is representing our third angles theorem. The third angles theorem tells us that if two of the angles of a triangle are congruent to each other, then the third angle must also be congruent. So we know that angle E is congruent to angle O. And again, the reason why, the third angle's theorem. Tells us that the third angle of the triangle must be congruent if the other two are congruent as well. Okay, this one here is just like the other one we did back on number 2. It uses our exterior angles theorem, which tells us the exterior angle here, 120, is congruent to or equal to the two non-adjacent angles. So 7x plus 11 plus 3x minus 1 equals 120. Now I'm just going to again solve for x. Now, this question does not ask this, but I'm going to go ahead and extend this and put an A, B, and a C here. And now I want to find the measure of angle B. So I'm just extending it. So with that, I know that angle B is 3x minus 1, the measure of angle B. X is 11. And it is a degree. It's a degree when you're finding the measure of the angle. It's just the number when I'm finding the value of the variable. Another good representation of what's on our test as well is that it just gives me a bunch of sides, a bunch of things, and says, hey, what's going on here? I have two triangles. It just gives me, I have to make a visual. That's the point. I don't have a visual. I need to make a visual. So it doesn't matter where I start. I just need to start with having my two triangles. So now it tells me AB is 60. Okay, it's AB. It's a distance on a side, outside. NO is 50. MN is 3x minus 3. And then these are angles, so we'll deal with those in a second. Now, with this, one thing I forgot to mention. Right here is my congruence statement. It tells me who's congruent to who, when, where, and why. It says that A is congruent to M. B is congruent to N, and C is congruent to O. The congruence statement is very important because it allows me then to understand who's going to match by my corresponding part. What's a corresponding part? A corresponds to M, angle B corresponds to N, angle C corresponds to O. That means side AB corresponds to side, it was AB, right? MN. Side BC corresponds to NO, and side CA corresponds to OM. Why is that important? Because corresponding sides of congruent figures are congruent. So therefore, right here, I know to find the value of x that the side 60 matches the side 3x minus 3, so I'm able to solve for x. Order again matters in this, that if I say side AB, M matches A, I have to say side MN. So here I know that 60 is equal to 3x minus 3 because AB here is congruent to MN. So now I can solve for x. Again, it is just a value. It is not, it's definitely not a degree here because it's the side. Definitely not. Now we move to part B. Part B says, hey, let's find y. So I have the measure of angle A is 103 degrees. That goes inside. It is a degreed measure. Angle O is 26. Well, it's actually degrees. So angle O is 26 degrees. Let's put the degrees on. Angle B is 3y. And it says, okay, find me some y. Well, the first thing we know, back to what we were talking about before, that angle O and angle C match, so this is also 26 degrees. Because they're the same, they're congruent, they match, they're the same measure. So now when I come to solve for the triangle for y, I know that the three angles of the triangle together equal 180 degrees. So now I know that 103 plus 3y plus 26 has to give me that 180 degrees that's inside of my triangle. So 129, I'm going to subtract 129 from both sides. Divide by 3, and y equals 17. And that's all about our corresponding parts of our congruent figures. They're all congruent. All right, on number 6, we're talking about reasons why triangles are congruent. It says, is it possible to prove that the triangles are congruent? If they are, state the postulate or theorem. Okay, there is only 5 reasons why triangles are congruent. Only 5. Okay, the first one we have is angle, angle, side. We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have hypotenuse, leg. Those are the only reasons that a triangle can be congruent. Nothing else. There are other reasons things are congruent, but no other reasons why triangles are congruent. Those are the 5 specific reasons. So now, looking at our first triangle. If it fits into one of these categories, they're congruent. So let's look at what we've got here. It says, all right, we know that we have angle T and angle U are congruent. We know we have NS is congruent to SH. What's not listed, because I told you typically it's not, is my vertical angle. So now I have an angle, the next angle, and a side. The corresponding angle, the next angle, and a side. So this one's congruent by angle, angle, side. Okay, looking at our second one right here, coming right over here. Now, I notice a right angle. With a right angle, hypotenuse leg has to have a right angle, but if it has a right angle, it doesn't have to necessarily be hypotenuse leg. It's just the only one hypotenuse leg can talk about. So, when we're looking at this one here, because this one's got a right angle as well, but it doesn't necessarily mean they're the same. All right, so where is my hypotenuse and where is my leg? If you remember in a right triangle, the legs sit around the angle. That's my legs. And they're not necessarily congruent. I was just pointing, sorry. And then my hypotenuse sits across from my right angle. It's the longer side. It is my diagonal. So now, looking at this picture here, again, the one marking they don't mark is my reflexive property because I'm reflexive to myself. So AC is congruent to itself. So now, looking at this picture here, what do I have congruent? I have a side, I have an angle, and I have a side. I do not have hypotenuse leg because this is my hypotenuse AD. That is not what is congruent. So therefore, it's a side, an angle, and a side because the angle has to sit between the two. So this is a good case where it's a 90-degree angle, but it's not hypotenuse leg. It's just the only option you have, and my hypotenuse, again, is not touched. Okay, looking at our third picture. Again, who is not listed? My BD being congruent to BD. And now I have a side that matches a side that matches a side that matches a side, so he's congruent by side, side, side. All right, now we're going to come down to the fourth one right here. Again, my reflexive property is not ever done, but we know it's there. So now I have the right angle, but in this case here, we can't have, well, we can't have side, side, angle, or angle, side, side, because we don't cuss in math, and it is a right angle, so therefore it can be hypotenuse leg. That is a leg, that is the hypotenuse, that's who I'm referencing, hypotenuse leg. And again, in my last triangle, my reflexive side, I don't know why I put 2 marks, but that's okay. My reflexive side is reflexive to itself. So I have an angle, a side, and an angle, a side, and an angle. These are the only 5 reasons that a triangle is congruent to another triangle. Only 5. Memorize them. They will not be listed on your test. All right, just kind of piggybacking off of that, it says, what else needs to be congruent to prove triangle ABC is congruent to triangle MNO? Well, we know that we have a side and we have a side, so what are we missing? Well, remember my 5 things. Angle, angle, side, but I don't have 2 angles. Side, 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 there's no way to prove my third side. Side, angle, side, if I know this, then I know I can have this. Okay. Angle, side, angle. I don't have another angle and there's no way to get there. And hypotenuse leg, I don't have a right triangle. So I need to know that angle B is congruent to angle N to prove it by side, angle, side. All right, MNO is an isosceles triangle where MN equals ON. Which 2 angles are congruent? Okay, first of all, need a visual, need to draw it. Second of all, when there's no segment over this, we're not talking about congruent sides, we're talking about their equality, their distance. So now, let's draw it and see what we got. All right, so I have my triangle. Doesn't matter what order I put them in, no, but you know they do go in order, MNN. I could have started here, MNN, MNO. Doesn't matter where I started drawing my triangle. Now I'm going to come back. It says my marking says that MN is equal to ON. So with my base angles theorem, it tells me if 2 sides of my triangle are congruent, then the angles opposite the side are also congruent. So angle opposite the side, angle opposite the side. So angle M is congruent to angle O. These are my base angles. Which makes the base angles theorem. All right, triangle CDE is an isosceles triangle with vertex angle D. Bam, that's a lot of information. So let's draw that first. Triangle CDE is an isosceles triangle with vertex D. Okay, vertex D means D is at the top. I'm just pointing to my vertex angle. That's D. The vertex, you know, is in between the 2 congruent legs. That's important to know. If this is my vertex, these are my 2 legs that are congruent, because the vertex angle sits between the 2 legs of the isosceles triangle. So now, what is the length of the base? When CD, which is the side, is 5x minus 35. ED is x plus 1. And CE is 2x minus 3. How am I going to know? How am I going to figure this out? I'm just given a bunch of sides. Well, that's easy because I know here this side is congruent to this side. So 5x minus 35 is equal to x plus 1. When you're talking sides, you got to know look for the congruency step. So let me bring my x over. So I'm going to subtract x from both sides. I'm going to add 35 to both sides. Divide by 4. So x is 9, but that's not what it asks me. It says, what's the length of my base? What's the length of my base? The length of my base, CE, because CE is my base. How do I know that? Because these are my congruent sides. That's my vertex angle. That's my base. It just uses vocabulary here, guys. You have to know the vocabulary. So my base is 2x minus 3. So CE equals 16. Sorry. CE equals 16. You have to know the vocabulary for the isosceles triangle. If you don't know the vocabulary, you won't know what sides are equal to who and what I need to put together. Okay, now it says here, so that's just the answer here. What's the length of the base? So that's my base. All right, so now it says, which side is opposite angle C? The side that is opposite angle C, here's angle C, that is the side opposite, so it's DE. And it's important to understand that because this vocabulary comes back to get us again next unit and later when we talk about polygons and quadrilaterals. You need to know what opposite sides are. Which angle is opposite side CD? CD. So here's side CD. The angle that's opposite of the side is angle E. Now it says the measure of angle D is 90. So if D is 90, name it by its angles. Well, if D is not equal to 90, then naming it by its angles, it has to be a right triangle, 190-degree angle. Be careful with that because sometimes on the test, it's just changing this right here. It might just say angle D is less than 90. If it's less than 90, you know that that's an acute angle, but you've got to be careful with what you're reading mathematically. If the measure of angle D is greater than 90, then we know it's an obtuse angle, so then in case that would be an obtuse triangle. So you need to kind of watch what the math is telling us right here in this scenario here. This is going to tell me what I'm looking for. Got to read directions. All right, we have another one that says triangle TOM is isosceles with vertex angle O. First thing I'm going to do, you got it, draw the picture. And that's my vertex angle, so these two are my congruent sides. He's just congruent to himself, and I'll just put it there so you know he's the vertex angle. Okay, if the measure of angle T, so this angle here is 5x minus 6, and the measure of angle O here is 2x, what's angle M? All right, well, first of all, what do I know about the three angles of a triangle? They equal 180 degrees. So I know that 5x minus 6 plus 2x, wait a minute, what is angle M to equal 180 degrees? What's angle M? Well, again, they told us that in the very beginning. If he's the vertex angle here, these two sides are congruent. That means my base angles theorem says T is congruent to M, so therefore M is 5x minus 6. So we do know what M is to be able to complete the task. I'm going to repeat that one more time. We know that he's our vertex angle. If he's isosceles, the vertex angle sits between the two congruent sides. So because he sits between the two congruent sides, the base angles theorem tells me if these two are my congruent sides, the angles opposite the sides are congruent, and they're my base angles. So T and M are my base angles, so therefore they are congruent to each other. Now it's just all the math. 12x, because 5, 10, 11, 12, minus 12 equals 180. I'm going to add 12 to both sides. I'm going to divide by 12. All right, that's what x equals, but is that what it's asking me? No, 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 no. Up here it's asking me to find the measure of angle M. So I know that the measure of angle M is this. I know that x is 16. And I know then the measure of angle M is 74 degrees. This is one of those things, guys, that you're going to jump on it and get the x and forget to take it all the way out. Make sure you answer the question, because it's wrong if you don't answer the question. It's not right if you had a good idea of what the question should be. This one right here is just kind of reiterating how to find all the angle measures that we know. So we want to find 1, 2, and 7. So 1 and 2 and 7. So the first thing I know is 1, I got parallel lines. I like to highlight my parallel lines so I can see them and I don't forget about them. So that's my own personal deal. You don't have to do that, but I like to highlight them so I can see them. Because when I have parallel lines, I have 4 reasons or 4 things that are congruent or 4 things that happen. When I've got a parallel line, I've got alternate interior angles that are congruent. I've got alternate exterior angles that are congruent. I've got consecutive interior that's 180, and I've got corresponding angles that are congruent. So I got a lot of things that can happen just because those 2 lines are parallel. So I'm going to start with the easy schmeezy first. So I'm going to come back to my parallel lines. First, I got a vertical angle just sitting here waiting to happen. So if I have 110, automatically my vertical angle says angle 9 is 110. I have a straight line here. So automatically that's 180 degrees across my straight line. So angle 3 is going to be 70 degrees. Angle 4 is vertical, 70 degrees. So right away, I got rid of 3, 9, and 4. None of the ones I wanted, but maybe it'll help me find somebody later. But they're the easiest ones because it's just a vertical angle and then a supplementary angle. So they're the easiest ones to find. All right, so now, let's go back. I kind of like my triangle. So I found a little triangle here. Up here I've got a triangle. So when I have a triangle, how many degrees do I have? Correct, I have 180 degrees. So here I know that the measure of angle 1 is going to be 180 minus 110 minus 30. That's what it's going to equal. It's 180 degrees total, but I got to subtract these off to find the missing angle. So I know the measure of angle 1 is going to be 40, or in here, 40 degrees. I'm going to go ahead and list it in case I need it later. All right, so now, looking for angle 2. Well, angle 2 is not that bad to find because I found this being vertical, because I just jumped on that right away. So therefore, I know that with this being a triangle like this, now they equal 180 degrees. So I know that the measure of angle 2 is going to be 180 minus the 65 that's there, minus the 70 we already found there. So the measure of angle 2 is going to be 45 degrees. All right, now we're looking for the measure of angle 7. He's going to take a little more work to find the measure of angle 7. Well, actually, probably not. With the measure of angle 7, I'm going to fall back on my parallel lines. I have these two lines that are parallel. I have a 7 here, and if I draw my transversal here, these are alternate interior angles. So the measure of angle 7 is just 30 degrees. Did I have to find 8, 5, or 6? No, but I could, because again, I could have another transversal, so these two would match 180. You know, I could go find the other ones. I don't need to find the other ones, but I might have to find some that I didn't think I had to find just to make the ones I have work. So I don't have to find the other angles. Always look for parallel lines. The first thing I always spot in my pictures are supplementary, triangles, vertical angles, because they're the easiest to do something with. Then I look for my parallel lines because I got a lot of congruence stuff or 180 stuff happening with that. Those are the only things you're really going to find to make the puzzle complete. Okay? So I'll write that down for those who want to kind of think about that. But the first thing I looked for was my vertical angles. Because you will have one similar to this on your test. So I look for my vertical angles because they're congruent. Then I look for my supplementary angles. Because they equal 180, and they're always going to be a straight line. When I talk about supplementary, I'm talking about the straight line. So more of a linear pair than I guess supplementary, more of a linear pair. Then I look, do I have a triangle? Because triangles make 180 degrees. And then I look to see if I have parallel lines. If I have parallel lines, again, I have my alternate interior that are congruent, corresponding that are congruent. Alternate exterior can happen, not as much, and consecutive interiors, 180. So these four things, just like there's five things to know with triangles that make them congruent. That's the side, 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 angle, angle, side, side, angle, side, angle, and hypotenuse leg. There are 4 reasons why that can happen when lines are parallel. Things you just have to memorize. You know them for life. Which now brings us to our favorite part of the day, writing a proof. Our favorite part of the day. All right, we're going to write a proof. I'm going to go ahead and write a 2-column proof. Cannot recall if there is a flow proof on your test, but if there is, it would be fill in the blank. You do have 2 proofs that you're going to have to write from scratch on this test. I've been promising this for a couple months now, actually. So the first thing I'm going to do is write my given. Now my given's not stated. It's actually just stated right here, so I'm going to write it off the chart. On your test, your given will be stated, okay? It won't just be in a picture. They should have really had a given right there, and I apologize if I had noticed it up front. I would have written it down for you, but that's fine. We can write it down right here. It tells us right here that MQ is parallel to NT. So right away, I got a parallel action going, and that's going to be a given. And then I know that MQ is also going to be congruent to NT. And that's a given. Again, on your test, the given will be stated up here in the given spot. Okay? Just so happens this one did not have one. I did not notice it up front, or I would have written that in. All right. So now let's get started. Immediately, what do I notice? Immediately, no matter what, reflexive property. This right here is reflexive to itself. Immediately, I'm going to mark my picture so I can see what's going on. And I'm going to say MT is congruent to itself because of my reflexive property. And again, you need to write the word property, or it will take a half a point or a point off. It's not just reflexive. All right, so to get a piece of a side, I'm going to have to prove the triangle first, because that's going to be that corresponding parts of congruent triangles are congruent. So if I'm not proving the triangle and I'm proving a piece, I'm going to have to get the triangle. So that's going to be my next step. How can I get the triangle? Well, right away again, I see I've got my parallel lines. Right away again, I have two sides. So I know that side angle side is a reason triangles are congruent. So can I get the two angles, or the angle that's in between? Sure, because if he's a transversal, then I know that this is congruent to this because they become alternate interior angles. They become alternate interior angles. That angle right there is congruent to that angle right there. So I have to write it by its, I can't just say angle M because we don't know that. So angle QMT is congruent to angle MTN, alternate angles congruence theorem, or alternate angles are congruent. You have to either state it or put the theorem. Now, by side angle side, my two triangles are congruent. Now, here it doesn't matter the order. It just matters your vertexes in the middle of the two. Here, order matters. I have to make sure that my corresponding sides are going to match. Now that my triangles are congruent to each other, every little piece is congruent. So now MN can be congruent to TQ. And that's that corresponding parts of congruent triangles are congruent. That also, someone had mentioned in class, could you use definition of congruent figures? Yes, because the figures are congruent, it means all of its pieces are congruent. So you can also put in here as a reason definition of congruent figures. It is the same thing, same reasoning. All right, bam, proof number 2. Again, didn't notice until right now the given is not stated, so that's okay. We can pull it right off the picture. You, again, will not have to pull it off the picture. It will be stated for you in your given at the top of your paper. So we're trying to prove the piece again, so we're going to have to use that CPTCT thing, okay, corresponding parts. So first, what do I know in my picture? I know that angle D is going to be congruent to angle C. And again, you don't have to pull it off the picture. It will be stated for you. I know that AB is congruent to BE. All right, automatically, I've got an angle in the middle. Bam, bam. I've got a vertical angle going on. Again, I can't just say angle B. Vertical angle congruence theorem, or you can just state vertical angles are congruent, which is what the theorem states. All right, so now I've got an angle, matching angle, a matching side. Now my two triangles are congruent. Here, order matters. And again, immediately following this is always this. Because once I have the triangle, I've got every piece of the triangle. So you're never going to have that corresponding parts without having a triangle directly above it. If you don't have this directly above this, it's not right. Because here I'm saying the whole triangle is congruent. Now I got pieces that are congruent. And most of you are getting so much better with your theorems, so much better. A few of you are still not doing where you need to be, but most of you are getting where you need to be with those theorems. And last but not least, my last little theorem of the day. Again, it has a given. Again, it has a proof. This one happens to be fill in the blank. You will not have a fill in the blank on your test, but I wanted you to see one more theorem. So here, it tells me FG is congruent to FJ. It's in my given. FG and FJ. I'm going to mark it. Mark the picture. Mark, mark, mark. All right, it says the base angles theorem. Okay, if I get rid of this angle right here, this marking right here, and I just look at the isosceles triangle GFJ, these here, G and J, are base angles because these two sides are congruent. You can see that on my picture. So these two sides are congruent. There's my base angles. So G and J are my base angles. And this one was more so that you can see where your base angles would be. Because you're going to have some kind of funky pictures like this, and you're going to have to find some missing or different pieces. Then I see HG is congruent to IJ. Again, those should be the ones we never miss. All right, so now by side, angle, side. I have a side and angle aside, a side and angle aside. So that's where my triangle is. And I should know it's a triangle because that's a triangle congruence theorem. So triangle what? FGH congruent to triangle FJI. And then last, to have the little bitty bitty pieces here, to have this piece congruent to this piece, definition of congruent figures or corresponding parts congruent triangles are congruent. I have to say it. I can't just put the CPCTC out there. Again, to kind of summarize a few things, you need to know vocabulary for your isosceles triangle. Who's my vertex? Who's my base? How do I come up with my base? That kind of stuff. You need to know the exterior angles theorem. You need to know that the total sum of a triangle is 180. You need to know the 5 reasons triangles are congruent. And pretty much that's everything on the test. So thank you for reviewing with me, and if you have any questions, certainly bring them to class to clarify. Thank you.